So solid-state battery and solid-state electrolytes have been around even before the commercial lithium-ion battery. The first commercial example of solid-state is actually in 1968, where a lithium metal anode and an iodine PVP glass polymer composite were commercialized by Catalyst Research Corporation for medical batteries, which were put inside the body. So this is 1968. Glass solid electrolyte with lithium metal anode. Very much a concept of today. Okay, then this is one commercial example. Then in 2010, this company called Blue Solutions, which was a spin-off of the French company Bolloré, they commercialized since 2010 all solid-state batteries, again with lithium metal anode. But now the solid electrolyte is the PEO polymer. So they use this 1973 technology, the PEO polymer. So this is the second example. So now we have two quite established examples of commercial solid-state batteries. Then, of course, we have a bunch of other applications. So these batteries that Blue Solutions made were large format for EV applications, and they're put in electric vehicles ever since. These batteries were smaller, much smaller in size, implanted in the body. Then we have a bunch of commercial applications for thin film batteries based on this material called lipon. These again are glasses, which have been some commercial applications for thin film batteries. These are usually used in some circuit boards, for example. So now, I should put it, I don't have an example of a company that has done that, but this would be a third type of commercial battery. So then commercial lithium-ion starts being commercial in 1990, 1991, as we know it today. And in 2003, Tesla uses them for EVs. It's the same tech, right? Same tech. So even before that, we've had commercial solid-state batteries. The problem is that all these three examples of technologies, all these three types of solid electrolytes have very low conductivity. And the most successful in the applications that are of interest today is the polymer. But the polymer is the easiest to manufacture. It is doesn't react with moisture, doesn't react with air, easy to scale. But the conductivity is about 100 times smaller than liquid electrolytes. So then we have new types of solid electrolytes which were promised to improve that conductivity. We have glasses in 2000s. Okay, oops. These glasses, basically Toyota jumped on that right away. We have an upgrade of that. We have upgrades 10 years later with a new type of sulfide glass, and then Solid Power jumps on that right away. So these are higher conductivity material than PEO polymer. But guess what? They react with water, they react with air. So impossible to scale, at least so far, because this is one class, sulfide glasses. Another class is the latest version of oxide ceramics at LZO, invented by the Max Planck Institute in Germany. So QuantumScape jumps on that. Okay, this is more recent. Again, very successful company. But guess what? Reacts with water. So it's very difficult because of moisture in the air, very difficult to scale and remain high conductivity. So the only commercial example for high size cells that has been already commercial is the polymers, but conductivity very low. So this is one area where basically our technology has shown improvement. But it's interesting to see how all these companies, which are now billion-dollar companies, they jump on pre-existing technology. They do not invent their own technology. So this is something where, again, we have value.